The objective of this video is to learn how to form equations to solve energy-related problems. Let us consider a falling ball. Let us choose 3 points along its fall for analysis. We will call these 3 points A, B and C. At A, the ball is at its maximum height. At B, the ball is at any point between the maximum height and the ground. At C, the ball is at the point just before it hits the ground. The points that you select can be random, but easier to consider extreme points as some of the variables will become zero, which makes calculation and explanation easier. At A, the ball is at the maximum height and is stationary, therefore its velocity is zero. Or it has been thrown up and reaches maximum height and is momentarily stationary, therefore its velocity is zero. So energy in the kinetic store at maximum height is zero. When the ball is held high, it possesses energy in the gravitational potential store. We can also express the energy of the ball with the following mathematical expression: total energy at A is equal to energy in gravitational potential store at A plus energy in kinetic store at A. At B, the ball is falling. The ball is somewhere between the maximum height and the ground. As the ball falls, its velocity increases, therefore its energy in the kinetic store increases. As it gets nearer to the ground, its vertical height decreases. Therefore its energy in the gravitational potential store decreases. We can also express the energy of the ball with the following mathematical expression: total energy at B is equal to energy in gravitational potential store at B plus energy in kinetic store at B. At C, the ball is just about to hit the ground. At this point, the vertical height is considered to be zero. So energy in the gravitational potential store is zero. Its velocity is the maximum just before impact with the ground. So the energy in the kinetic store is the greatest. We can also express the energy of the ball with the following mathematical expression: total energy at C is equal to energy in gravitational potential store at C plus energy in kinetic store at C. Recall the principle of conservation of energy. Energy cannot be created nor destroyed. It can be transferred from one form to another. The total energy within a system remains the same. That means that as the ball falls, its vertical height decreases. Therefore its energy in the gravitational potential store decreases. Its speed also increases. Therefore its energy in the kinetic store increases. That means that during the fall, the energy in the gravitational potential store is transferred to energy in the kinetic store. Total energy at every point is the sum of energy in the gravitational potential store and energy in the kinetic store. According to the principle of conservation of energy, the total energy at every point must be constant. So the total energy at A is equal to the total energy at B, and the total energy at B is equal to the total energy at C, therefore the total energy at A is equal to the total energy at C. Use this concept to form equations to solve problems.